All right, welcome once again, everyone, to this video series on introduction to database management systems and SQL. And today's topic is again we'll be continuing on SQL queries. We will be looking into some of the other complicated mechanisms that you have, some other type of queries that you can create, and let's see where we can go from there. Okay, before we get started, a gentle reminder that this course is being brought to you by the Launchpad initiative by Newton School. The link to the Newton School's website is going to be given in the description section, so do check that out. You can view this video in YouTube, or you can register for this particular course from Newton School's site. For registration, you need to come to the Newton School's website, log in or sign up depending on whether you are a returning user or whether you're a new user. Once you have logged in, you will be redirected to your dashboard where you will be able to see all the tracks and the Launchpad tracks that you are currently registered for. Out here, look for the course on database management system and SQL. You can apply for the course here. It's a free course, so anyone can apply. Once you have applied for this course, the extra benefit that you get is that along with the videos, you will also be getting daily quizzes, assignments, and once you have completed the course, you will be given an opportunity to get a certificate as well. Also, there will be doubt clearance sessions. So in case you're watching the video later and you have certain doubts, you can always go to the doubt clearance sessions, and you can also post your doubts on Newton School and someone will get back to you on that. All right. Having said that, let us come to today's topic. So today's topic, as we mentioned before, is going to be again SQL queries. So we will be continuing with the queries, SQL queries topic that we were working on in the last video. So we ended the last video in trying to create a many-to-many relationship, modeling a many-to-many relationship between three tables, the student table, the course table, and the bridge table in between them, the student courses table, because the student to course relationship, as we saw, it was a many-to-many relationship. Okay, so we will start directly with the code. Let us go to the playground and create a new playground here. So we shall call it as, let's say, SQL queries 3 data. So Newton School's playground gives you a unique opportunity to use any programming language and keep all your code in one single place. So if you want to code on something like Java, C, C#, or something like that, or if you want to do SQL coding like we're doing, you have got the options to do that. So once you're in the playground, choose a language to SQL. So currently SQLite is supported here. Okay, and here you go. So now before we can get started, we obviously need to create the data. That is, we need to create our the tables and everything. So for that, we already had done that yesterday. So I'm just going to be I'm going to be just doing some kind of copy paste. I'm not going to be explaining each and everything because this is something which we had already done in the last sessions. Let me also enter some data. Okay. So the initial statements were the create statements for creating the tables, and then I inserted the data, some dummy data inserted into the tables of the students and the other one. Now what I'm going to be doing is I will also be creating, or rather I'll be showing you exactly how to do. There you go. The course table next to come up front. Yeah. So now I'm creating the course table, and I'm creating the student course table. So course table is again, it will contain all the courses, course ID, name, and everything. And student course is going to be containing a relationship between the student table and the course table. So that's kind of like a bridge table, as we say. Once again, we'll be inserting data into them. Okay. Now I'm just simply going to run it to ensure that there are no compilation errors. It's running fine, so that means there are no compilation errors. So we will first initially start with the last query that we saw yesterday as to how we can join tables, join three tables. So let us just do select star first, and from the tables now we need to join is first is a student table, and let us alias it with S. We understood what was aliasing. Aliasing is actually giving a user-friendly moniker to a existing table so that we can reference that table later using a user-friendly character. So I'm going to be joining this with the student course table. So student course table, let us call it an SC. And then when I'm joining, I need to tell on which attribute. So here we have got the student has got the roll number. And in the student course, we have got the student row. So these are the two attributes that I'm using. Quick reminder, in the student course table, we have got the student role attribute, which is nothing but referencing the student table's role number attribute. So that's the reason why you're using this to connect. Now, once we have connected the student with the student course table, what happens is one big table gets created. That is the student table and the data that is present in the student course table. Both the data, they get created into a single table. Like, let me go ahead and run this. So if you run this, you see here we have got the student details. And once the student details are over, we have the student course details. So a big table has been created. Now with this table, if I need to connect the course table, how do I do it? The way to do that is the last column that you are seeing here, 5342123. This is the course ID. So now with this table, I need to inner join the course table. So I do again inner join, and I say course C on, and again C dot course ID is equal to SC dot course ID. So that is the column. Again, quick reminder, if you come up and see the student course table has got a course ID, and this course ID is nothing but a foreign key, which is referencing the course ID in the course table. So that's what I've done. Let me run this. So what I'm going to get is I'm going to get a huge table now with the student details. Then we have got the student course detail, which is acting as a bridge between these two tables, followed by the course details. Now, definitely, I don't want all this big information. So let me just select only a few things. So probably I'll just be needing the student name. I'll be needing, let's say, the student CGPA. I'll be needing, and what is the course that they have taken. Let's say I'll just take the course name here. Just go ahead and run this. There you go. So the same data, but obviously we're selecting only a little bit of less number of properties. So we are good for that. Okay. All right. So this is what we did till yesterday. So this is what we had seen as to how we can do that. Now what we'll be doing is we'll be trying to add some more complications into it. Now the first thing is, and this is not really a complication in the queries, but this is when you're doing some data design, this is something which we need to keep in mind, is that the student course table we see, we have two identities. And they are foreign keys. Both of them are foreign keys. Like this, the student role is a foreign key to the student table. Course ID is a foreign key to the course table. But what we don't have in this table is a primary key. This table does not have any primary key. All the other tables that we have designed, they all of them had a primary key. So having a primary key is actually when it comes to the data definition, to ensure that your data remains clean, it is always imperative that you have a primary key. And it is also helpful for running a lot of queries. It helps because primary key automatically kind of becomes a clustered index. So since it becomes an index, you can actually use that index for speeding up a table. In one of the later video series, we will understand about what is exactly meant by indexing. But so far, let us just try to understand that if you do not have a primary key, there can be some performance issues, or there can be some issues later in when you are trying to have huge number of data. So a good question here would be, what can be a good primary key here? Now we see student role definitely cannot be a primary key because one student can have multiple courses. So the student roll number is going to get repeated. So that's not a good idea. So that cannot be a primary key. Course ID, again, the same problem is going to happen. Like multiple students can take the same course. The course ID is also going to be repeated across a table. However, if we combine both of this, if we combine both student roll number and the course ID, then we see that it becomes unique. That is, one student can take only one particular student can take only one particular course only once. It cannot be like the same student take the course twice. That is not possible. So if I take both the student role and the course ID, that combination becomes unique for me. So that is a unique combination. So that is something which can be a primary key. Because if you remember in some of the earlier videos, when we were discussing the theory of SQL and relational databases, we said that a primary key can be a single key, or it can be a collection of multiple keys as well. So if multiple keys together, they give uniqueness to a particular table, then that can be considered to be a primary key. So if I can create a primary key which comprises of both these two values. Now, how do I do that? Till now, we have been only marking a single attribute as a primary key. And for that, when I was defining the attribute, that is when I was saying that what will be the data type of that attribute and everything, we were mentioning that to be a primary key. But here I cannot do that because primary key now comprises of two things. So what we do here is, so this is the way how we write our constraints. Our constraint will be, let's say, primary key given, and give both the tables or both the attributes which you want it to be the thing. Let's just run it to ensure that there is no compilation error. Yeah, it is running fine. So this is working well. So this kind of syntax can be used when you want multiple attributes to be the primary key for a particular table. If you want only a single attribute to be a primary key for a table, then this kind of a syntax is okay. But for multiple keys, this is something which you need to follow. And we will test it also. So let us do one thing. Let us try to insert a duplicate here. That is, we have already inserted student roll number 5 with course ID 2. Let us try to reinsert that once more and see what happens. Now, if I run this, I get a standard error, and the standard error says unique constraint failed student course student course dot student role and student course dot course ID. So it is saying that some kind of a unique constraint has been kept up on the student course table where this is failing. And which constraint it is? It is a primary key constraint. Primary key states that you cannot have means a duplicates, right? Because primary key is one of those attribute or those set of attributes which can uniquely identify a record in a table, right? So if you try to create two records having the same primary key, this is obviously going to be a violation of the uniqueness, the unique constraint. So that is exactly what the message is saying. Unique constraint failed. So something like that we cannot do. So let us go ahead and delete it. We don't want any trouble. Let us go ahead and run it once more. And yeah, it is working fine as expected. So no problem in that. So we were done here. Good. So far we have just inner joined 3 tables. Now what we'll do is let's go back into the course table, and there is a very interesting thing that is there. There is a department table as well, a department here as well, and the department attribute is connected to the department table. So this department attribute is a foreign key which is referencing the department table into the course from the course table. Now what exactly is this department table? So this department is nothing but that which department is offering this course. So if you're going into a college, then like the course cannot just be coming from anywhere. It has to be managed and maintained by a particular department, and that department is going to allot faculties like the lecturers and everything to that particular course who will be teaching that course. They will be deciding the syllabus and everything like that. So it makes perfect sense to have a department reference in the course table so that we can know that which department is offering this course. So since there is a reference from the course table to the department table, I can inner join this as well. That is, I can join, like currently what I've done is I've joined the student table with the course table using the bridge table in the middle. Now I can take the course table and join it with the department table. So let us go ahead and do that. So I can do inner join. Again, I will say department, and let's call it a CD. CD on. Now C has got a department and CD has got a department. I think deft ID is the right name. Yeah. Let me go ahead and figure this. Again, it is going to run, but probably we'll just add something else here. We will be adding the department name also. So I'll say CD dot depth code. The code is good enough. Let's run this. So now what we'll be seeing in the record, we are seeing the name of the student, the CGPA that the student has received, the course that the student has taken, and which department offers this course. Now this is important. See, when we have joined the department table, I'm joining the department table with the course table. So whatever values, so whatever department is offering this course, I'm joining that version of department. This is going to become really interesting in the next query. But this is important, that to which table I'm joining this department table, because I could have joined the department table with some other table as well. And if we think carefully, and let us go back to the student table, if you see the student table definition, even the student table definition has got a foreign key reference to the department table. So student table has got something called a department ID attribute, which is connected to the department table. So in this table, so if I just take this inner join out for a moment, in this table that we have created using the student and the courses, you can connect to the department table in 2 ways. Either which course is either via the course route, that is which department is offering which course, or via the student route. And in the student route, how we'll be joining, that is which student belongs to which department. So here, when you're joining the department table, you can join it in 2 ways. So first way, as we said, is using the course way, that is I'm joining it with the course. Next thing let us do, I'll again join the same table, again join the department table, but this time I'll alias it as SD, and I'll say SD dot depth ID. We will just keep it this way so that it is a little easier to understand. Yeah, not I'm just changing this, equal to, again I'm going to do s dot, I think I made a spelling error in the department. Yeah, that's why I'm going to copy it. This is going to start crying. If I run this again, nothing is going to happen, nothing is going to change. It is still going to work. But here, what I'm going to be doing is I'm going to just make a small change, and I'm going to also add est.depth code. Let's go ahead and run this. Now look what has happened. Now this is interesting. What has happened? Again, the department is getting printed, but I'm printing sd.department code. And sd is what? Sd is the department which is connected via the student route, via the student table. So SD is actually telling me the department of the student. CD is connected, is again the department table only, but it is connected via the course route. That's why CD is telling me which department is offering the course. But SD is telling me the student belongs to which department. So I've got the first student who's belonging to MME, has taken a subject called microbiology, and that subject microbiology is being offered by the biotechnology department. This is what this particular record means. A student named Manju Verma, carrying a CGPA of 9.1 from the metallurgical department, has taken a course called microbiology, which is being offered by the biotechnology department. Similarly, if we take something random here, so here again it is a very easy thing where Anuj Tyagi, a student of mechanical department, has taken a course called steam engines, which is being offered by the mechanical engineering department only. Now, to visualize this a little bit theoretically, let us try to go back to the slides. So these are the 5 tables in play here. First is the student table. So student table is offered in this color here. So these are the student tables data that I'm picking up. Next, the student table, I am joining it with the student course table. Okay. So this is the student course table here. So student and the student course table, we are joining it via the roll number. Okay. So this is the first join that we have done here. Student.roll number is equal to student.sc.student roll number. So if you look at it into from the perspective of the code, we have the student table which has got the student roll number, which has got the roll number attribute, and we have got the student course table, which contains the student role attribute, which is referencing the student table. So using that, we have connected first the student table. So this is a student table that we have. Sorry. There is a student table that we have here, which is marked in this color, and this is connected with the student course table, which is marked in this color using the roll number. Next, the student course is getting attached with the course table, and how we are doing that? Using the course IDs. So here it is. We using the course ID. We are simply attaching them. So this table, course table, is getting attached to the student course table using the course ID. Now the course ID is getting, or the course table is getting attached to the department. Now, what does the course and the department? Now, what does this department and this course have in common? That is which department is offering this particular course. So this is how these two getting connected. We are once again connecting department. So after we have connected all this, we are once again connecting department with the student table using the student's department ID. So there are actually 5 tables at play here. 5 tables are getting connected, and you can see the department table based on where it has been connected. It has got two different values. So actually, although you are connecting only 4 tables, that is student course and department, but since you are connecting department in 2 flavors, that is, once you are connecting department using the via the student table, and once you are connecting the department via the course table, that's the reason why department is getting replicated twice. And based on against whom you have connected, the values of it is changing. Like for example, let's take this example. So this student's department is CSE. That's the reason when the last department value that you are saying, that is the data from the department table that is coming, this one has got a value of CSE. However, this record has got a course called microprocessor, and microprocessor is a course which is offered by the electrical engineering department. So that is the reason when we are connecting this version of department with the course, the value is become E. So the whole concept of this is, or the whole point of having this discussion there is that you can connect a single table multiple times. You can inner join it multiple times to a particular from clause. But based on how you're joining it, that is against which attribute of which table you're joining it, the value of that will be different. So that is exactly what we saw here. Now, before I go ahead and do some more complicated queries or more advanced queries on something like this, I would like to just take a look into the live chat as to whether there are any questions or doubts so far. Okay, no questions and doubts so far. That's fine. So this is for everyone who's watching this course live or later. That is, if you have any doubts, you can, if you're watching it live, you can post it on the live chat and we'll try to get back to you as soon as possible. And if you're watching this course later, then you can post your queries in the comment section and we'll get back to you. Or you can post this question in, if you're registered in Newton's school website for this particular course, you can post it in the doubt clearance session there as well. Okay. Carrying on. So we have got we have got this query now created, which is now kind of joining 4 tables, but in 5 different versions, variants, you can say. So let us now try to do some where on this. So see, so for the where that we did it only on two tables now. But at the end of the day, all that your inner join is doing is, it is nothing but it is creating a bigger table. Like for example, this inner join actually created a table by combining 4 or 5 different tables. So if you're creating a 4 or 5 different tables, if you're doing a where, that is, if you're keeping a where clause which is used only for filtering, you can filter on any of these columns, or sorry, any of these rows, or rather you can filter any of these rows based on whatever columns are available to you. Since you have joined here 4 or 5 tables, all those columns are available to you. And since all those columns are available to you, you can use any of the columns to do the filtering. So let's do that. And here the first filter that we'll be doing is, now I want to know that, okay, how many students have taken a course which is offered by the computer science department. Okay, so what we can do that is, now see, when I'm trying to now filter by the course, by the department which is offering a particular course, which version of department should I do? Should I take CD or should I take SD? I should take CD, right? Because see, what I'm trying to do is, I'm trying to get the department which is offering a particular course. And for that, we have alias that with CD, because CD is the one which is joined with the course table. SD is that version of the department, or that alias of the department which is joined with the students department. So now here, since I want to know that who are the students and their details who have taken a course offered by the computer science department, I will need to use CD. So I'll take CD dot depth code is equal to, let's say, CAC. So this is, that is, I'm filtering all those I'm getting only those rows where the CD dot department code is CAC. Let me go ahead and run that. And here it is. So we have got, these are the students, so like who has taken courses from offered by the CAC department. So you can say object-oriented programming, database management systems. These are the courses which are offered by the CAC department, and these are the students who have undertaken that. Okay. Now let's make this query a little more interesting. Now what I'm saying is, okay, fine, that I want to know who are the CAC students, or rather, who are the non-CAC students who have taken CAC courses. That is, who are the students who do not belong to the computer science department, but they have taken the taken a subject offered by the computer science offered by computer science department. So the question for that is that, how do we do that is, so see, now we need to target the department that a student is belonging to, and we need to write some query on that. And which version of department should we target? We should target the SD version. And the reason why we should target the SD version is because the SD version of the department is one which is connected to a student's department. So my query is, I need to know all those students who do not belong in the computer science department. So let us first do that. Let's first write that. So I am all the students who do not belong to the computer science department. So I take SD dot depth code not equal to CAC. Okay. So this is going to give me all the students who do not belong to the CAC department. And those students must have taken a course offered by the CAC department, and we just saw it in the last query how to do that. I'll just do CD dot depth code is equal to CAC. Let me go ahead and run that. So here it is. Answer is Manju Verma and Anush Tyagi. These are two students who belong. So first student belongs to the MME department, second student belongs to the mechanical department, and both have taken one subject which belongs to the CAC department. So this is how we can get it. That these are all the students who does not belong to the CSE department, but have taken a course which is offered by the CSE department. So we can play around with this select queries, and we can have a lot of other things. Now let's try to make something even more generic here. And what we are going to be making here is, let's say, so right now I want that, okay, that I have taken all the courses taken by the CSE department and the students don't belong to the CSE department. What if I say the query, or what if I try to write a query where I say that, hey, I want to know all those student details who has taken a course that doesn't belong to their department. That is something like this. So here we are doing specifically for the CSE department, but this can be for anything. Like I want to know any student who has taken at least one course that does not belong to his or her department, his or her actual department. This is, and how do we do that? So what it specifically means is that the students department, which is sd.department code, and the CD department code, which is the courses department, ideally they should not match. Now, if I again go back to this diagram to make it more sense. So what I'm saying is, this two version of departments that we have, if this two version of department do not match, that means that student belongs to a different department but has taken a course offered by a different department, right? Because if this column tells you the department for which the course belongs to, and this column takes you the department to which the student belongs to. So if they do not equal, if they do not equate to each other, if these values are not equal to each other, then what does that mean? That means the student belongs to a different department, but the student has taken at least one course which doesn't belong to his own parent department, his or her own parent department. So it's simple. So I'll say sd.department code is the one which represents the department that the student belongs to, and cd.department code represents the department code which the course that the student has undertaken belongs to. So if I simply say where students department is not equal to the course department, that should only do it. Now let me run it. And there it is. These are the students. So you can see Manju Verma's name got repeated thrice because this student belongs to the MME department but has taken a course from microbiology, has taken a course from steam engines, has taken a course from CSE. Riya Mishra also belongs to the biotechnology department but has taken a course offered by the mechanical department. Anush Tyagi belongs to the mechanical department, taken a course called object-oriented programming, which is offered by the CSE department. So that is exactly what we wanted to find, and that is what we have got. All right. So we are almost done with this thing. This thing in the sense like we have seen some of the queries, and now what we'll be doing is till now we are only getting data. That is, we are only querying data from the tables, and we were displaying it in various types of form. We were doing some where clause into it, where we're trying to put some complicated filters so that we can filter some records and everything. Now let us look into something interesting where we'll actually be updating a record. That is, we'll be changing our already inserted record. So for that, we will start with something very simple, and then we'll try to get into something really complicated, especially on the cascades and everything. So let's do one thing. What we'll do is, first let me just select star from student, where let's say student or roll number. Let's just pick up the random student, okay? And the random student is, let's say, Pratik B. Okay. Now what I want to do is, let's say there is a reason, something has happened, and I need to update the name of the student. Like let's say the student's name has changed, or the student's name was inserted by mistake, as a wrong name got inserted and stuff like that. So let's say I need to update the name of the student. So how do I do that? So this is where the next we will be learning about the next type of thing, or the next type of command known as the update command. So the update command is used specifically for updating a record in a table. So update, I need to now tell which table I'm updating. So I'm updating, let's say, the student table. So that's the first thing I say, that hey, which table I'm updating. Next thing I need to tell that which attribute I'm updating, and I'm setting the attribute to what now. So let's say I want to change the name, and I want to change the name of the student from Pratik B to Pratik Bhattacharya. So if I need to do that, I am updating which attribute of the student table? I'm updating the student name attribute. I'll say set student name to, and what will be the new value? The new value is, let's say, my full name, which is, let's say, Pratik Bhattacharya. Okay. So the first two things are done. Now the third thing that we need to tell is, for which student am I doing this? That is, I have already told that, hey, which table I'm targeting. I have also told which attribute I'm targeting and what will be the new value of the attribute. But now the question is which one? That is let's just confusion on this one. So I've got also now the question is, but which row I want to update? Like, do I want to update a single row or multiple rows also? But which row I want to update? So let's say I'm trying to update this row here, that is this one. So to do that, next what I need to give is again the where clause. So the where clause works exactly similar to how the where clause was working in the select query, that it is used to filter certain rows based on some condition. And here the condition is I just want to update the value for student with roll number 2. That is this particular student. So let us go ahead and do that. Where I'll say roll number is equal to 2. That's it. Now after this is done, I'll once again print the students. So just to give you something like this, I'll just say after update. This is so that we can verify, that what was the record before update and after update. So after update, I'm again selecting all the students. Now we'll see what the difference will be. So let's run it. Okay. So first here again, Pratik B only got printed because here we are printing the student without update. We have simply inserted the data, and the data that we inserted was Pratik B. Here it is. We have inserted Pratik B. That is why Pratik B is getting printed as the name. Now here it is after update. That is now this statement is completed. Here if you see the same student, the name is now Pratik Bhattacharya. So the record has been updated. It is as simple as that. Now, one thing you need to be careful is about the where statement, that if you give a where statement can actually select multiple rows, right? Like it is not always that the where statement will select only a single row. So if that is the case, so what that is actually means is that you can end up adding something like, in case your where statement selects multiple rows, you may end up updating multiple records at the same time. So those are things that can also happen. Or rather, if you want to do that, like let's say you have a query which says for all the students who have got greater than 8.5, update some special attributes, like probably like let's say I want to update that in their name itself in the bracket that these are 9 pointers or these are 8 pointers, something like that. I'm just giving you examples. So in that situation, your where statement is going to give you back multiple records. So when you are updating, all those records are going to get updated. So those are things that you need to be careful about when you're doing the update. If you do not give your where statement properly, you might end up updating things that you did not want to update. Okay. So this was one version of the update actually, where we just updated a single query, updated a table, and we saw how it looks like. Now what we'll do is we'll do something again a little interesting in the sense. So we just saw a query. Let me just go back to the original query. That is we're looking into the we're looking into this query, right? That is the, I'll just make it as department name actually. Let me get rid of the subject. So what this query was doing was, this query was actually giving us the student subjects that the student has, the code that the student has taken, and what is the department to which the student belongs to, as well as the department to which the course belongs to. The course is being offered by which department. Now let's do one thing. What I'm going to be doing here is I'm updating one of the department name itself. Let's say the biotechnology department that we have, I don't want to name it as biotech. I want to name it as biotechnology and engineering. Let's say because of some domain change that has happened, the requirement has come. The biotech department's name should be updated to biotechnology and engineering. So doing that is going to be pretty simple. So what I'm going to be doing is something like, let's say update, and we know already how to do that. Update. So now I'm going to be updating the department table, right? So let me update the department table. And what I'm going to be doing is I'm going to be setting the department name, and I'm going to be setting the department name, new name, to biotechnology and engineering. Okay. And again, I'm going to go where clause, because I need to tell that in the department table that we have, which are the rows that I want to update, and I want to update only those rows only the biotech department too, right? So I'll just put it as where depth code is equal to BT. Okay. Let us do something more interesting. Let's say that what I'll be doing now is let's update another table. We will be updating let's say one of the subjects as well. So let's say I say that the subject that we have object-oriented programming. Let us update that subject name to object-oriented programming and Java. So again, I need to update the course table now because that's a table that I'm trying to update. What I'm going to be setting, I'm going to set the course name because that is what I'm changing. I'm going to set the course name to object-oriented programming with Java. Let's say this is with Java and C. So I'm just adding only one. Okay. And which one I'm going to be updating? I'm going to be updating where the course ID is equal to. Let us go ahead and check that. So let's pull up the courses what I've inserted. So it's or maybe I'll do it by the course code. Where course code is equal to OP001. Okay. Update statement that I've done. Okay. Now, once the update is over, let us once again select the same thing. Let us once again query for the same records, and we'll see the differences now. And I'll do something like this select. This is just to give you a kind of a visualization tool, which will tell us that whether the update was completed or whether the data before update and after update. Okay, all right. Let us go ahead and run it. So the initial, okay, I think I made some error here. Save statement. I did not end the statement. That's why. No error. Okay. So first here we got printed the same value got printed. No difference here. Now let us see what happens after update. After update, the same records are there, but you can see that the course name is updated. Like biotechnology has become biotechnology and engineering. So even as part of the subject course, like see whatever we had biotechnology here, like as part of the course department or as part of the students department, it has got updated everywhere. Biotechnology and engineering, it has got updated everywhere now. Here. So it has got updated. Similarly, if we say the object-oriented programming, so object-oriented programming, this subject it has been used in those two places. Now, if you come here, we'll see object-oriented programming with Java and C#. So that exact update has happened. And this you see is actually one of the huge advantage of using a relational database. Like when you need data like this, which contains a lot of things like a student name, student ID, course, department, and stuff like that, and you want to update one particular thing like a department name or a course name, and you want that to be reflected everywhere, that is wherever I'm using, this is where relational database really comes into picture and they really help. So you see, we just updated these two tables. We didn't update really anything else. Just updated these two tables. We did not make any change in the query. This is exactly the same query that I've copy pasted here. But now the value now this query has started reflecting the new value, and it is doing it automatically. There is nothing. There is no change in the query that you need to do, and that's the biggest advantage that you get with SQL, where once you have reduced all the redundancies. That is, there is no data copy and everything. Everything is lying in only one table. Like if you want to get the information about courses or if you want to get information about departments, you have to always go into the department table. No other table has storing those kind of information. Other tables are simply referencing the department table. So, and you need to update something in the department table. You just go ahead and update the department table. All the other queries, no matter how complicated they are, they will automatically get updated. This is like a biggest or rather a huge advantage that you have with something like a relational database. Okay, so now that we have seen update, we will be seeing something else. Now we will be seeing delete, and delete is actually very interesting. And the reason why delete is interesting is, so now when you are deleting, this is where a lot of the foreign key constraints and everything comes into picture. Because now when you are deleting, let's say you are deleting a particular department. So what happens to the students who belongs to the department? We should ideally delete them as well. Let's say I'm saying that, hey, from today onwards, we will not be offering the biotechnology department anymore, or will not be offering the mechanical engineering department anymore. So what happens with the students who are already in the database, who are being tagged with mechanical engineering department? So what we are going to be doing them is we also should ideally delete them, because if the department doesn't exist, why do we need to give the students there? So if I go into now the foreign key, since the foreign key cascades and everything comes into the picture. So the student table has got a department ID as a foreign key, and we are saying on delete cascade. So what it essentially means is, from the department table, if I'm deleting something, that deletion should be cascaded to the student table as well. The same thing is going to happen to the courses table. Remember, because the course table is also connected. What is that? The course table is also connected to the department table. So if I am removing one record from the department table, then all the courses which were associated with the department should also get deleted. And this is exactly what we have seen here, is told here, that the department attribute of the course table references the department table, and on deletion, we should cascade it. All right, let us try to see a demo for that. But yeah, obviously, like before we try to see a kind of a demonstration for that, we also need to do a simple thing in SQLite, something called the pragma. So what exactly the pragma does is that the foreign keys in SQLite in some of the version, and I think in this version is also no different. The foreign keys is cascading and everything, they do not get switched on by default. You need to kind of tell SQLite, hey, you know what? When I'm using foreign keys and I'm using the foreign key constraints and I'm using something like cascade delete, you need to honor that. By default, it is not honored by SQLite. So that's why we need to just write a pragma. We're saying that the foreign keys must be switched on. Okay, we have done that. Now we will try to do some deletion. So in deletion, what we will do here is, let us simply get all the students first. Select start from students. Or what I'll do here is, I'll join this with the department table so that it's easier to understand. Dep ID, and I need the, let's say, the s dot student role, s dot student name, and let's say d dot department. Okay. I've done this. Now let me delete, and the delete statement is something like this. You just say delete. Next you tell from which table. So I'm going to be deleting from the department table, all right? And then I'm going to be telling, okay, in department table, what exactly am I going to delete? And I'm saying I'm going to be deleting those department whose code is, so let us say I'm going to be deleting CSE department. So where department code is CSE. Okay. And I'll take again the same query, exact same query that I was running earlier. Let me pull that as well. Fine. And let's see what happens. Okay. Foreign question failed. I did something. I think I might have inserted a student who doesn't belong to a particular department. Let's say 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 5. Department ID is looking fine. Foreign key constraint field, line number 89. All right, okay, that's a problem. So microprocessor. So I don't have a department 6 actually. Let me insert a department number 6. Yeah, so that's a very interesting thing happens. See, till now when you're running the queries, this error never came. Right now, error came. And why this error came? Because right now we are actually enforcing the foreign key constraints. Till now we are not enforcing the foreign key constraint in SQLite. We are telling SQLite that, you know what, I've created a foreign key, but you do not need to enforce the constraints. But now we are enforcing the constraints. That's the reason why these errors have started coming. So it's saying that I don't have a department. So I'm trying to actually insert a course which doesn't belong to a particular department. So I've got department 6 here. Let's call it as E. I'll call it as electrical engineering. Another 104 and 114 also it failed, it seems. So 104 values 2 courses. This shouldn't have failed. 2 and 114. It's 5 and 6. So 5 and 6 it makes sense. Let's go ahead and run this and let's see if it again comes up. Okay. All right. Now some other syntax error has happened. 122 from student S. Sorry, my bad here. Roll number. This will also be roll number here. Okay, I think we're good now. Let's go ahead and run this. Yeah, all right. All the errors are gone. So initially this is the first this is the result that we're seeing here. This query. So where I'm seeing like Manju Verma, Pratik Bhattacharya, they're all there. After deletion, look at this. Earlier we had let's say Pratik B from Computer Science Department. We had Pragati Singh from the Computer Science Department. We had Sripanna Saha from the Computer Science Department. We do not have Pratik B anymore. We do not have Pragati Singh anymore. We do not have Sripanna Saha anymore in this new table. And why did that happen? Because the department table, because a CSE department that I'm talking about, that itself has been deleted. And since that has been deleted, and the student table had a cascading effect to it, that is the student table and the department table, when they're connected to the foreign key, we had a cascade delete, a constant here, like here there's a constant I'm talking about. All these departments or all these students also got deleted. Let me do something else as well. From instead of student, I'll show you the same example with courses as well now. Select start from course. I don't want to go very deep into it, but just select start from course will do. Here, try the same thing again. And there you see these subjects like database management system, object-oriented programming, these were offered by the CSE department. After the deletion statement, you see these tables, these two values, object-oriented programming, database management system, they have also been deleted. And the reason for that is similar, because the course table also has got the foreign key reference to the department table, and we have got a cascade delete operation on it. So every time something gets deleted on the course department table, the course table also gets updated. And then another huge advantage of using relational model, especially when you've got a lot of such relations and you have got like, I can delete a particular course and I want that deletion to take effect in all the other queries that we have, or I want to delete a particular department and then that department, and when I delete the department, all students should get deleted, all courses should get cleaned up and everything. That is, I don't want any inconsistencies in my database. Relational database helps you a lot in doing that, and SQL query languages, helps you with the kind of tools and commands that you have. The SQL helps you to achieve that. I'll once again pause for a couple of minutes to go into the next topic to see whether there are any questions on live chat. There aren't. Okay, fine. Okay, since there are no questions on live chat, we'll carry on with the next portion. So this is a portion that we'll be starting today, and then obviously in the next set of video series we will be continuing it. So although in the next set of video series we will be looking into advanced concepts like hashing, indexing, normalization, but we'll also, along with it, we'll also be looking into some interesting queries as well. Those sessions will be like divided into, some session will do queries and some session will do some advanced theoretical concepts. Okay. All right, let's carry on. So now that we have done, so till now what we're doing is that we were only pulling up single records, or rather we were just pulling up records from a table, but we're not doing any kind of mathematical operation on it. That is, we're not doing any operation on the data that we had. We are simply pulling data. We're pulling data, we're filtering data and stuff like that. Now SQL gives you an opportunity to do some mathematical operation, to do some aggregation on it as well. So we have some aggregation function. Again, this is not an exhaustive list. There are other aggregation functions as well, but these are some of the most commonly used aggregate functions. That's why I mentioned it. So there are functions like sum, count, average, max, mean. What they do is, if you give it a certain set of values, that is, let's say you give it a certain set of numbers and SQL can automatically add them for you. It can count how many values were there. It can do an average of that value. It can get the maximum value. It can get the minimum value and stuff like that. So that is what is known as the aggregated function. So we will see that in example, and that is going to make it a little more clear exactly what is max, min and stuff like that they do. So let's take, okay, here when you're doing, let's say something like maximizing something or taking the minimum value of something, the best thing that we can do is, if you look into our domain, is something on the CGPA. So I can always get it, right? Hey, you know what? I need to know what is the maximum CGPA, or I want to know what is the minimum CGPA, or what is the average CGPA that the students are receiving. And also, like, if you're doing a lot of interesting or complicated statistical function, you can say, I want to see the standard deviation in the CGPA that the students are receiving. Yeah, so those are the things that you can do. Like if you're doing some statistics, some machine learning and stuff like that, you will be able to do that. But let us try with something very simple. So I'll say as a student. Okay. Now what I want to know is, I want to know what is the maximum CGPA that I have received. So very simple. I've got max, and I just say CGPA. Let me know that. And what do we have is the result is 9.48, and that is actually true because, and there's another way of figuring out whether this is the right result or not. So what we'll do is select start from student, order by CGPA, and descending order. So let me go ahead and trigger both the queries, or maybe I'll just take this query out. Let me trigger this. So if I trigger this queries, what is going to happen is I'm going to get you see all the students are sorted by the marks, and we see that Pratik B has received the highest CGPA of 9.48. So now when I'm doing actually select max CGPA, the answer should come as 9.48 because 9.48 is indeed the maximum CGPA, and you can see the minimum CGPA is 6.5. So let me do it this way: max CGPA in CGPA. So I should be getting 9.48 as a maximum CGPA and 6.5 as a minimum CGPA. I've tested it. Let's run that. There you go, 9.48 and 6.5, exactly what we're looking for. Now, what if I want average CGPA? AVG is the function. So probably I'll keep it in the middle. Average CGPA, minimum CGPA, and the maximum CGPA. Done. So as simple as that. So you've got the maximum CGPA, the average CGPA, and then you've got minimum CGPA. So these are the three information that I wanted from this table, and I've got it. So that's as simple as that. Now let's try to do a little bit of more work on this particular CGPA thing. So let's say, so I've got 9.48 here. So what it internally actually has done it, when I say select maximum CGPA, what it has internally done is actually selected that row which had the maximum CGPA, and it is simply printing that. So here along with CGPA, if I also the student name, this will get printed. So that is Pratik, we have got the maximum CGPA, and even if I do the min CGPA, Vijay Kumar have the minimum CGPA. However, you need to be careful in this. Like if you're actually trying to print out the records, like if I suddenly say now, let's say average CGPA, and if I print this, see what is going to happen is it's going to take the first record. And it has taken Manju Verma. The reason why it has taken Manju Verma is because Manju Verma was the first student who was inserted in the table. Because when I'm doing average CGPA, it is not really choosing a particular row, right? It is taking all the CGPA, doing some calculation, getting the average, and just printing the value. So now when I'm saying that print the average CGPA along with the student name, it hasn't really picked up one particular row, right? So it is just going to by default pick up the first student value that it has got and is going to print the student name. So that is wrong. That is incorrect. So that's why so that's why if you're doing it with max CGPA and min CGPA, it works fine, because for max CGPA, it has actually selected only a single row which contains the maximum CGPA. A similar thing goes with min CGPA also, that it has only selected a single row for the student which has received the minimum CGPA. So we are able to print the student details along with the minimum and the maximum CGPA. But when you're doing something like average, standard deviation, or count, or stuff like that, in those situations, we really cannot be doing that. Okay. Now, probably this is where we will be ending the video lecture today. So in the next session, we will be doing some advanced concepts like normalization. We'll see what exactly normalization is. But before normalization, we'll also be looking into a lot of SQL queries. That is, we'll be looking into the aggregated functions and the group by functions. So we have just touched upon aggregated functions where I showed you like max, min, average. You can actually write complicated queries on it. Like for example, I want to know all the students who have received at least this or who has received more than the average CGPA of the class. That is, I want to know the average above average students who are present. I can also make it complicated, and here I say that I don't want that max CGPA. I want the max CGPA, but I want the max CGPA per department. So that is something known as group by functions. So there are some interesting aggregates and group by things that we will be doing. So that's something that we will be keeping it for the next session. So before that, I'll again just verify whether there were any questions asked in the live chat. All right, doesn't seem like there has been any questions on the live chat, so that's fine. So probably we will end this. We'll call it a day tonight. And once again, thank you everyone for attending this session. I do hope you get to learn something. If you have any positive feedback, please feel free to give those feedbacks either in the comment section, or there is a feedback link given in the description section as well. So please feel free to put in your feedbacks about how this session is going. So once again, thank you everyone, and have a great day.